And welcome again to SanfordFlipMath. This is PreCalculus, and we are again looking at examples that correspond to the book Demana, Waits, Foley, Kennedy, PreCalculus, Graphical, Numerical, Algebraically, excuse me. And we're continuing with section 5 in the book, and this is really just meant to be an extra video, a supplemental video, with just some more examples of looking at transformations. This is all about transformations on functions. We're going to try and get 3 more examples in, and I want to deal with some stuff that's not so pretty. Okay, so let's look at, let's do squeezing it in here. Missed my 2. Let's do 2x plus 4 cubed. Okay, and so looking at this equation, probably worth noting that the parent function is just going to be x cubed, the simplest version of this. And you may or may not be aware that x cubed looks kind of like x squared, except the left side's kind of twisted down. It's a little steeper because of the higher exponents, but it's not that big of a deal. Looks something like this, and that's really not the reason I want to do this so much about the cubed. I just need to do it on something. And the issue here is that I have a combination of multiplication and addition or subtraction on the inside, and so that means I have some kind of a scale change and some kind of a translation all at the same time. And that's really not a big deal if they were both on the outside, or one on the inside, one on the outside. But because they're both on the inside, it makes that inverse issue a little more complicated. So remember how we do inside is inverse. And let me just say that the inverse of 2x plus 4, some people are going to want to say 2x minus 4. That ain't it. Some people are going to say 1/2 x minus 4. That ain't it either. And so the problem is that what does inverse really mean? Now, if you go back in time, let's say to Algebra 2, maybe even a little bit of Algebra 1, well, if all I have is addition, inverse is subtraction. If all I have is multiplication, the inverse is division. But if it gets a little more complicated than that, the inverse in terms of functions, in terms of equations, really means switch x and y, solve for y. Well, that sounds like a mess, especially if all we're talking about is 2x plus 4. I don't even see a y. Well, I'm going to throw one in because we need to make this equal to something. All right, sorry about that little phone call thing going on in there. Hopefully you didn't really notice it. All right, so I need to look at this inside, this 2x plus 4, and the only way for me to really do the whole switch the x and y, solve for y thing is if I make it equal to y. Okay, so what I'm going to do is switch x and y. Okay, so now this is x equals 2y plus 4, and now I'm going to solve for y. So I'm going to subtract 4 from both sides, and I'll divide both sides by 2. Now, this is okay, but it kind of masks what's going on, so I'm going to do just one more step. This x is being divided by 2. I'm going to write that as 1/2 x. This minus 4, or negative 4, is being divided by 2, so minus 2. Oops, sorry, I got a little excited there. Okay, now I'm not happy with it at all. Okay, 1/2 x minus 2 is y. So this is what really happens to the x values. Okay, so I just did the inverse. Okay, so it is 1/2 x minus 2. So you can split this up, but there's really no reason to. I'm going to call this a linear change, and it is 1/2 x minus 2. The y's are not affected. Okay, so in terms of wording, this was a horizontal shrink of 1/2, a shift or slide left of 2. Notice the order I put that in. I have the shrink or stretch first because it's about multiplication or division, and the shift after that. In terms of how can I make this happen? Well, there are a couple of different options. one way to go is just take these points and do the wording. So it's going to shrink 1/2. So what's half? I'm thinking about the x values. This is all about x's. Okay. X value, half of 0 is 0. Shift left 2. There it is. Half of 1 is a half. Shift left 2. Half of -1 is -1/2. Shift left 2. Okay, so here it comes. It's a little narrower because it actually is shrunk horizontally. Okay, a little hard to see, so let me highlight it. Okay, oh, why does it do that? Must be something to do with my motion. That's cool. I don't want it to do that though. All right, I don't know if this will matter. Okay, so that's my final image. Okay, now one other quick note here. You could actually drop points into the linear notation. For instance, I could take 0, 0 and make it become, well, 1/2 of 0 minus 2 would make this -2, and then the y value stays 0. 1, 1, I'm not going to do this for all of them, I'll just do this one. Okay, so 1/2 times 1 minus 2 is going to be -1 and 1/2. And the y value stayed the same. So here's that point. Okay. All right. So a little ugly when you have a combination. The only time this is ever an issue is if you have a combination of multiplication and division for x. Okay, you have to do the inverse. And the inverse, if it's more than one operation, then it's actually more like this. Okay? All right, now I know that's a mess now, but you can rewind it to find a better spot. That was the last video. Okay. Okay. Okay, well that was sneaky, wasn't it? I just wrote that while we're on pause. All right, so what we're going to do is write an equation for a parent function y equals cosine x. And the cool thing about this is you really don't need to know anything about y equals cosine x as a graph. I mean, it's cool if you do, and really you should from last year, but that doesn't mean that it really is an issue here. All you need to understand is this is the inside of the function. You can picture little parentheses here holding that sucker by itself if you wish. Okay? All right, so here we go. This is about x. It's horizontal. So it needs to go inside, and it needs to be inverse. Well, I only have a single operation here, so it's really not going to be a big deal. I'm just going to put x plus 3 on the inside of y equals cosine. So y equals, okay, I'm just going to write the cosine here, and on the inside, I need x plus 3. And there it is. Okay. Next up, I need 1/2 to multiply the y values. Now remember, multiplying is a stretch or a shrink. This would be a vertical shrink of 1/2. Not really an issue here. But remember, if this is about y, it's on the outside. And you keep it the same. You do what it says. You don't have to, do anything crazy like the inverse of 1/2 is 2 or -1/2, depending on what you're doing with it. So I can just multiply by 1/2 out here in front, and then I need a plus 1 on the end. Well, you know what? We're done. That was fun. All right. Next up, honestly, that was it. All right, this is a lot of fun. Okay, and by a lot of fun, I mean yuck. Okay. It's really not any harder if you understand what's going on, but the problem is you can't type this into your calculator. There's just no way to do it unless you're going to figure out what the equation for each of these three pieces are. Like, for instance, this is a piece, that's a piece, that's a piece. And you could do a little piecewise function, but it's really not an easy thing to do in terms of typing into your calculator. So I wouldn't do it. So what you're looking at is a graph of y equals f of x. And what we're going to do is do some transformations on this. So let's do negative f of x minus 3. Okay? So things to think about. A negative typically does some kind of a reflection. Well, this one is on the outside. So that means it changes the y values. And if it makes the y values opposite, well, that means positive y values become negative, and negative y values become positive. So in effect, this is a reflection over the x-axis. Okay, so I need to get rid of my crazy red arrows that are here for no apparent reason. Okay, so what we're going to do is, well, let me also mention that we have some subtraction inside. Now, just a reminder that inside is about x, in other words, horizontal, and we have to do the inverse. Okay, now you keep hearing me say that, but I'm going to keep saying it and keep saying it, inside inverse. So that means this really becomes x plus 3, or in other words, a shift right 3. Okay. All right, well, I typically do transformations like this that are a combination of either stretching and shrinking or flipping and shifting. I typically do them in 2 steps. I do all of my stretching, shrinking, flipping, and then I do the shifting on a separate graph. Okay, so I'm going to deal with the reflection first. Okay, and again, the idea here is the y values change sign. So I'm going to locate specific points that are easy to identify, like that guy right there. Its y value is 0, and when it changes signs, it will be 0. It's actually pretty easy to do them first because they don't go anywhere. Okay, so that's really it for those. Now there are other points that I want to key in on though. So for instance, this guy right here. This point has a y value of -2. Well, when I do the opposite y value, it becomes +2. Okay, so let me get rid of that thing. Thank you. This guy has a y value of 3. When I do its opposite sign, it becomes -3. Now, as I'm going along here, I don't want to get too far ahead of myself. I want to kind of connect them in the same way they were connected originally, so that way I don't lose track of what's going on. Okay? And then I'm going to pick just a couple of points on this straight line thing and see where they go. Okay? So like this one has a y value of 2. It's going to become -2. Remember, all I'm doing is changing the sign. This has a y value of 4. I'm going to make it -4. Okay, and so I'm just going to draw a little line through there, and that keeps going. And that's it. Okay, so my image for this one, well, okay, that's it. Spoke too soon. That's it for the reflection. Okay, now this next thing said, remember it was -3, but inverse from the inside, so that means +3 on the graph. So that means I'm really going to shift this to the right 3. I'm going to take those same points that I just keyed in on, and I'm going to move them right 3. So this guy, right 3. Right 3. Now, I wouldn't necessarily draw all of these little lines here every time. I'm just doing it so you see the motion of what's going on. Right 3. Right 3. Okay, yeah, these lines that are connecting things. Whoa, hello. Sorry about the bell. And then move those to the right 3 also. And there we go. Okay, one last thing. Okay, hang on. There it is. And that's it. All right, well, thanks. That's all we're going to do for now. Thanks for watching.